everyone. Thank you for joining us. I'm pleased to welcome you to the panel discussion on RISC-V trend in AI. As presented in this morning, we see there's a strong market growth of RISC-V, and that's a very, very exciting moment. On the other hand, we know that AI technology itself is evolving so fast. So I think it's crucial for us to get prepared. So it's important for us to discuss and prepare for the opportunities and the challenge ahead of us. Yeah, and today we have a great lineup of experts from the semiconductor industry. They all have a deep experience in computing and AI. So, let's please join me to welcome our panelists here. Okay, so I'm looking forward to a lively and insightful discussion. As we already have lots of presentation here and more at a high level, so I expect that our panel discussion will be more lively and have more discussion in detail. Okay, so I encourage you to ask questions in the Q&A section at the end of the discussion. Okay, so let's get started. So first, I'd like to talk about the RISC-V trend. And as presented according to the SHD market report, we saw that RISC-V is SoC marketing is achieving a very good business result in last year. With low do that tell us that the number itself is not that important. But I want to say that the 6 billion, there's more than 6 billion in revenue in 2023. And the analysis shows that there will be a compound annual growth rate of more than 40% till 2030. So, I think we are excited to learn from you what's the key factors that are driving the significant growth of the RISC-V, and how this factor or how the demands from this market will steer the future of the RISC-V, the technology itself, and as well as the ecosystem. So, Ludai, would you begin first?
Okay, I'll start with that. You know, I was just thinking about the questions, what drives the RISC-V growth. I think there's two ways to look at it. One is, you look at where RISC-V is used today, right? We already seen a lot of growth. We saw RISC-V is being discussed in AI, which is the key topic for this conference. We saw RISC-V discussed in automotive. We saw RISC-V discussed in a lot of new areas. And if you go to our summit in China, you see RISC-V is discussed everywhere. The one way to look at it is RISC-V, it allows the tremendous access to a CPU technology previously maybe only available to a few. It is, I'm trying to, maybe still Wei-Han's words when he was talking about AI is a new industrial revolution. RISC-V itself is also a new industrial revolution in our industry. The way to look at both is AI is leveling the playing field to make us who may not be, in our college, may feel not as smart as somebody else. With AI, we are becoming just as smart or smarter. RISC-V is also a leveling of playing field that you previously don't have access to a open CPU ISA that now you do have access. And not only you have access, it gives you even more flexible access, and that drives the growth for RISC-V.
Okay. Then how about Charlie? I see that Andes has a strong business growth as well, and you have many customers from the SoC industry. So could you share with us?
Yes. So I want to talk about things beyond AI and machine learning, even though it's kind of one of our biggest market. But for the RISC-V, there's a lot of opportunity there. So we started with deeply embedded processor, real-time processor in the application part, wireless, mobile, storage. For example, for Andis, we have customer using our processor from the small SD card all the way to enterprise SSD to data center SSD. So all had kind of belong to the same category, but they have different requirement to the processor. So certainly in the deeply embedded domain, RISC-V very mature already. We have all the needed tool our customer needs. They can just finish their development and then send it to their customer, and then their customer don't even need to know is what kind of processing inside, but they just enjoy the benefit RISC-V bringing a low power, higher performance because the customization, for example, extensibility. In our customer, in the storage part, they're actually using a lot of RISC-V extensibility to directly control their hardware. So this kind of extensibility enabled innovation. So one of the reasons is certainly because ARM is kind of stopping there. So in one part, RISC-V is today, in where we are, is because of RISC-V advantage. But the other part is thanks to ARM. They are stopping there. And it seems that for Cortex-M and Cortex-R series, they no longer have future roadmap there.
Mm-hmm. So. Okay, I see. So, Wei-Han, do you have something to add?
Yeah, I actually have a lot of insight about this. So last year I traveled 15 countries. I talked to government official, big enterprise, right? So what this semiconductor build out is actually coming from this pandemic, right? 2020. Everybody suddenly realized this global supply chain we actually entrust, last like 20 years actually completely broken where there's a supply chain shortage. And semiconductor has a very high economic leverage. If you have a car, say $30,000, you miss $10 chips, you cannot build it, right? So it's critically important for a country or in a big enterprise to ensure that they have a stable supply chain, right, for their semiconductor product, because the leverage is big. So for the nation, it's become a national security and economic security problem. So then that's why they start build up this semiconductor fab to ensure they have the production. And once you build a fab, then the natural question is that how are you going to fill the fab, right? So there are two things they're immediately looking at. One is the AI, one is the CPU. And CPU, right, from my understanding, CPU is basically the water and the electricity, right? Because current economy, if you don't have the processor, everything gonna broke, right? This is how important that is. And then you look on the CPU, where can you build, right? If you want to have a design capability. ARM is proprietary. X86 is basically closed by two companies. The only way you can build with a sustained technology investment is RISC-V, right? I have no doubt in my mind in the future, right, the RISC-V will be successful just because of this reason. For a country to invest long term, for the next 10, 20 years to building a sustainable technology, it has to be open. I cannot go back to ARM to renegotiate a license agreement. And ARM license, because its current contracts being signed, cannot be open in the future, right? Because it's violated the contract already signed with those licensees. RISC-V is the only solution. And that's why I certainly believe all the big company want to secure their supply design for the processor, and all the country want to do that. We're using RISC-V. It's just a matter of the time. So whatever you actually know, right, whatever you actually learn, you have question mark about the software ecosystem, the country will spend $100 billion to build that up for securing their national supply chain. So the growth is definitely there, right? So it's just a matter of the time. So I believe this growth is sustainable, explosive, even the ecosystem is actually mature. Yeah, that's my view. Yeah.
Okay, thank you.
Yeah, and I think building on what I was saying earlier about the pipeline from academia, getting ideas out there is so much more possible with the RISC-V ecosystem. ARM openly admits that they have a university problem because they don't have a way to license to universities. So x86, obviously there's no license to universities. But RISC-V, universities can do their research on the same architecture that is then going to drive to commercialization. And another example of this, if you look at the capabilities work done at Cambridge, they did it for many years on a MIPS technology base, and everyone was, yeah, that's nice, that's academic, no one's building MIPS anymore. And they tried to do a project with ARM with some success, but it was very much a closed project. But in RISC-V, they could bring their Cherry capabilities, they could set up a SIG. At the European Summit, we saw 2 or 3 other folks had built Cherry capabilities into RISC-V cores, into the Open CBA 6 core. We saw Microsoft had taken Cherry capabilities, built it into their Cherry IoT core. And that pipeline of novel ideas pushing out into the world can happen with RISC-V in a way that's just not possible in the other architectures. And that's going to propel us as well, because we can get the cutting edge from universities right out into the commercial world.
Okay, thank you. So interesting is, in the past, CPU is like water to us. And we are going to have an AI. So AI will be the food for us.
So AI is actually driving a new application, but CPU, there's a lot of traditional computation, storage management, communication, right? You have to have the CPU. I think the transition will have to happen. Like maybe in the future, data center will be 60%, but a lot of traditional computation will have to depend on the CPU. Right? So that's where I see like there's a replacement socket for the CPU in the future for the RISC-V, yeah.
Mm-hmm. Then following that, do you think RISC-V in the past, most people, their image on RISC-V is about CPU, the processor. So in the future, RISC-V will, AI will become an important part of RISC-V. Am I correct?
I think that the CPU is well standardized, right? So it has a very clear semantic functional interface going to the compiler. But AI, you don't have that, yes. Right? So the ISA semantic is such a clear defined, such a well-studied research, like 60, 70 years. So it's well standardized. So I don't expect AI will be solidified in that kind of stage and then being generalized in the next 10, 20 years, because we're not even figuring out how human brain is working, right? So I certainly believe RISC-V should do its own best, right? Do the general purpose compute, come with the best ISA, and whatever feature you have to support, hypervisor, data center, whatever. But don't go into the RISC-V, don't go to the AI space, try to create a standardize there, because we actually don't know what's the standard there, right? So yeah. I will be very hesitant to say, oh, that's creating an AI, ISA. I think that will be abandoned absolutely very quickly, just because nobody knows what is actually real AI applications. We are trying to figure out as well.
Yeah. So okay, yeah.
Yeah, and I think to build on that, where RISC-V comes out is in standardizing that other stuff. So it's not just the ISA, it's what's called the non-ISA specs, how interrupts work, how memory management works, IOMMUs, all these crucial things, that can be standardized very easily. I agree completely with Wei-Han. The AI stuff, it's all changing every day. If we tried to standardize on something, by the time we've got through all the debates of standardizing it, well, that's how we built models last year, not how we built models this year. So I think we have to be very careful on that. Now, there are components that we might want to build, like the matrix unit that obviously is used in lots of places, but I think we have to be very careful because Microsoft proposed some models that don't have matrix multiply in them. So, well, what if they take over? If we've just spent all our time building these fancy matrix units, we're going to be sad.
Yeah.
Yeah. I think RISC-V, as we started, is for all computing devices. So it's AI certainly currently is one of the major application. We should kind of from the foundation to see how to support that. From Andy's part, for example, custom extension, that's very important. But exactly what kind of instruction you're going to add, that depends on customer. But we want to lay out the tool for customer to adding all kind of instruction. And then same mechanism can be used for storage, for networking, and so on, right? So as the technology at the processor level, I think would be more generic. So we look at multiple application and map to the bottom to see what kind of support we need. So only that we can really kind of achieve our vision of for all computing devices.
Yeah, I mean, another way to look at it is like when we look at RISC-V for AI, this is like a hot topic, right? I mean, it's also the theme for this conference. But when you look at AI for RISC-V, if I use an analogy like, you know, when during the World War II, when you go to Europe and you did this D-Day in Normandy, and that's our AI, right? We're trying to establish our, you know, beachfront, get our first major success there. But we have the whole Europe in mind, and we have RISC-V. We want that to fit into everything, everywhere, right? Just like the previous ISA, they actually didn't define the ISA for a particular market. It was a general purpose, right? And then when it go to a special market, they just add additional co-processors. So look at that way is we can establish a RISC-V ecosystem that can potentially cover everything.
Okay, so then I think we can have more intensive discussion on AI, because actually when I'm thinking about organizing this panel discussion, I think this is pretty challenging, because RISC-V already cover a wide range, then AI almost cover everything. So the combination of coming together is a broad topic. So I personally think it's because we still need to have some sort of standard, right? To have a RISC-V compatible with each other. Though it's open source, but we still need to have some baseline ISA, have some customer ISA extension. However, on the other hand, AI, just what Wei-Han said, that AI itself is evolving so fast. So how can we, how can we combine this together to keep the ecosystem, compatible or well management, while get the RISC-V catch up with the fast pace of the AI technology itself. And so Wei-Han, I think you already present a lot on what Tenstorrent are doing now. Would you share your experience, how you deal with this, how you leverage the RISC-V part? On the other hand, you still can provide a product to catch up with the fast-paced AI technology advanced.
So the current processor ISA is a well understanding semantic, and also in terms of its capability. The computation industry is building 67 years behind us, right? So it's pervasive enough going to networking, general purpose processing, embedded application. AI problem is not only solving on the accelerator, you have to solve on the data movement, memory technology, right? So the data movement requires great network technology, then you have the faster speed to process the network. So you need an embedded CPU for that, right? So when you think about AI, you don't have to mix the AI acceleration or whatever into the RISC-V. RISC-V just have to do well on the traditional computation technology to serving the AI processing. Right? So my take on this is that keep the thing you're doing best, right? Doing best. Don't entrench to the area that it's not standardized, you cannot do best. Because everybody knows CPU is super inefficient doing something. Today, you look on the MPEG encoder decoder, no one trying to put in the RISC-V processor. Why is that? The accelerator is doing so well. Why do they standardize everybody how to do MPEG encoder? So why are we trying to do that? So my take on this is that go wherever you do best on the general purpose compute, traditional computation technology. Come with the best ISA to support that. There's still a long way to go for ISA. Don't go entrench into this AI acceleration engine because it's sexy, right? Everybody talk about it, oh, RISC-V will be part of AI because it's attractive, but it's not. I think it's not being at the stage that you should do this kind of work.
Okay. So then, Mark, do you have anything to add? Do you expect what's the priority task that RISC-V or RISC-V community should invest in for AI? Or you have anything to add?
You know, you can tell we come from the same background through the last 20, 30 years, can't you? But I absolutely agree. The pushing stuff into the RISC-V at this point is not ready. And I think the MPEG or picture codecs in general, if you roll back to the 90s, you know, JPEG was just forming, MPEG was just forming, everything was churn. And at that point, trying to do specialized hardware was not the right thing. Now, absolutely, everything's more fixed in those codec spaces. And in that case, and I think where we will get to with AI is it's definitely going to be a collaboration between CPU compute and accelerator compute. That's where it's going to go. So from the RISC-V point of view, what you need is to be able to enable that smooth coupling from CPU compute to accelerator compute. Now, everyone builds their accelerator different, so that's precisely where the RISC-V custom instructions come in. If you've got an accelerator and you want to hook it to your RISC-V core, you can use custom instructions to make that super efficient. That doesn't want to be in the standard because everyone's accelerator is different and what you put there is going to be different. But as we get to the stage where computation bounces back and forth between CPU compute and accelerator compute, using those custom, and that's where RISC-V has actually already done the right thing for AI and enable that custom instruction addition. And not try to say, well, let's assume the models are going to be the same as they are today because we know they're not. So I think very much agreement here.
Okay.
Yeah, I want to follow up on what Mark said, the computation bounds between accelerator and the processor. So it had to be the case. So, I mean, because application is not just all the same, right? So it's different code and also different form factor. So like the presentation I have for different SoC, usually for the low price application, you will use just one general purpose processor which is powerful enough to do everything. But when you want to, let's take for AI for example, want to specialize it and you want to have very high performance on your AI presentation in your application, you may want to have a dedicated accelerator to do that. But speaking about the RISC-V's extensibility, so even though you have a special hardware accelerator, but you can somehow fold that into part of the RISC-V ecosystem to instructionalize that acceleration so that your software can get visible to that and make it easier to do control, bringing to the software. So so I think it's not necessary that RISC-V cannot do everything. I mean, just kind of how we incorporate that. You can as a very separate coprocessor, or you can have very tightly coupled coprocessor. But still, you can issue one instruction and doing a lot of work there. Just that if you have the right programming model, so that is possible.
So what's a traditional computation model proposed by the processor is actually the determinism, right? So AI sub-symbolic computation is probabilistic. It's not secure. It's not deterministic, right? So it's very, very important to understand the differentials here. a lot of things cannot be processed by AI. I don't believe AI will eventually replace general purpose compute because the determinism you need for security, right? Like for this kind of thing, AI is doing very well on this subliminal symbolic neural inference kind of thing, image processing, probabilistic prediction, but it's not good at the deterministic thing. So there are a lot of things you still need to perform deterministic way, right? So you need a process to do that. So they're the process to do what is best. Like, but however, I do want to mention there's a software transition path, right? Software development for AI sometimes is very difficult to write into the AI accelerator. You take time. You write in a C code. You compile with certain metric multiplication. You can build a reasonable performance AI transformation before you spend tons of resource right throwing to the accelerator. So there's a transition story you can use the general purpose compute as a software transition story to the AI accelerator. That's the usage is there. But in the future, like I still think you need to focus on building the right, instruction ISA for RISC-V, but not to mingle that together. But that transitional usage is there, right? So, like Jim told me that, right? In his like 30, 40 years in compute, he never see a CPU is not being utilized in the SoC. You always can find a usage. I think for the future AI is the same thing. Doesn't matter you throw in how many accelerators, some people cannot just then program it. So you need the CPU writing the C program, PyTorch compiling and working in the day one. Then they can transition to the accelerator. So that path is actually there. So the RISC-V probably need to accommodate that usage model, but eventually you have to move to accelerator. Yeah.
Yeah, I think I just want to do a little bit clarification when people talking about RISC-V for AI or AI for RISC-V. We talk about AI, we could talk about it from an accelerator perspective. We can also talk about AI as the overall end goal for my SoC, right? So RISC-V, you can have an AI SoC with a RISC-V CPU in there. You can have that with an ARM CPU or x86 CPU. But what's the best fit for our AI purpose? And because of AI is fast growing, because we still are experimenting a lot of new algorithm, RISC-V's openness and its support for custom extension fits very well there. But sometimes when we talk about it, we are not talking into that level of details. We just say AI for RISC-V, right? You can probably understand AI is just a hot topic right now. If you're looking for any kind of venture capitalist, if you tell them that I'm building an accelerator, you're not going to get money. If you say, I'm building something for AI, yes, then we will talk.
So I think, Wei-Han, you just mentioned that the CPU take around 50 years to get the software now is highly compatible, for example, for the ARM or x86. So do you expect it is not the right time for RISC-V to deal with AI in that way because AI itself is evolving so fast. But do you think in the long run, as the AI algorithm become more established, then RISC-V will aggregate the common part and put it into the part of the ISA standard, maybe in the option or maybe in the baseline standard. Do you expect that will happen? Definitely, it not within the 5 years, maybe take 10 or even longer.
So if it's a well standardized, it actually using accelerator is the best. CPU has a lot of like microarchitecture, like branch predictor, prefetcher, cache hierarchy, low stop pipeline, reservation station, all consume tremendous amount of design complexity and power, right? So putting an ISA well-defined, well-accelerated to the CPU is basically a very inefficient way to execute those instructions, right? So I would say that even in the 20 years from now, right, it's very, very likely you have a dedicated accelerator for that. While your CPU doing the traditional computing like operating system management, previous mode, which is well understanding academia, how to do that kind of thing. So that kind of management task, right, running a traditional C program, like we actually using quite pervasively on the CPU, right? On the just I show you different hierarchy, right? So there's a PyTorch program you have to run, dispatch algorithm you have to do. You only CPU, and it's being done by Trentino CPU, and then everything had to be locking down together, optimized together to get the best performance. So RISC-V can serve in that market already very, very well, because we are actually trying to optimize every segment layer of the software on the particular PPA requirement for the processor. Without the open standard CPU, we cannot do that. We have to go in and say, I have to build this PPA, can I build it? That's a sign a license agreement. But this open standard, you can do basically whatever you want to do, right? It's a freedom, right? So there's so many things you can serve in AMI with the Trentino RISC-V. I don't quite believe the acceleration is actually should be hitting home here, right? So that's the accelerator do whatever they do well. Traditional operating system, privilege mode, security architecture, determinism and determinism is best doing by CPU. It cannot be doing by AI, right? So there's a clear segment about what the application is.
So how about Mark? What do
Well,
you think?
yeah. I mean, I think let's just to step aside from AI, because I think this might be easier to understand because there's a lot of mystery to AI at this stage. But if you look at the data processing, right? Traditional SQL, boring stuff. Sorry, everyone will fall asleep. But if you look at what the pipelines data scientists write, yes, maybe there's a hash join that they're doing, and that's inherently parallel, and you pass that to an accelerator. But then you've got some spaghetti Python to do some data filtering. That's not going to be on an accelerator. That's a CPU function. Let's let the accelerators do what the accelerators do best. Let's let the CPUs do what the CPUs do best. I really think that's going to be the case down the road. I think there's many things that will break up into this part of the problem, CPU. That's where RISC-V plays. That's where RISC-V can be really optimized. That's where we focus on adding instructions. Something inherently very parallel, something with a very specialized properties, that's where an accelerator comes in. And get them working together, yes, but try and commingle them, messy.
I see.
I think based on what you have heard from Mark and Wei-Han, based on what we know right now, we don't see that the accelerator portion is going to be integrated into our base size, right? But one thing is, we never say never. I mean, just people know, like back many years ago, the Intel x86 had a mass coprocessor, and we don't talk about mass coprocessor anymore, right? But what RISC-V has is, if you ever need to do that in future, your custom extension could be elevated to become a standard. Right now, you have no need. And if we do need it, and it could be going through what we call market-driven standardization, may the best winner win, right?
So I think RISC-V as a consortium, as a community, open standard. I think the speed that I don't know where ARM is, when ARM started to kind of start eating the x86 Intel's lunch, but I think that speed with RISC-V probably 2x, 3x faster because of the community. But on the other hand, today in data center, AI accelerator, not just accelerator, so hopefully I can get the funding. So AI accelerator, basically you plug into the x86 server, right? So one server, you can plug in many AI accelerator box, and the whole value chain together actually accelerator even higher than the server itself. So what I want to say is that even though Intel might be there still for a while, but focusing on AI accelerator still can allow the value for RISC-V community as a whole.
Okay. Okay. Maybe, yeah.
Can I just make one more point on this topic? It doesn't mean there isn't some smaller AI problems that were done on the CPU, right? This is one of the reasons why the matrix extensions are being explored. Matrix multipliers It's a very important building block of AI. It's a very important building block for HPC applications too. So having something like that standardized so that you can do small AI just on the processor, absolutely. But trying to say, let's do an extension for transformers, let's do an extension for, you know, whatever comes out of Stanford next month, it's not going to help us. But you know, small amounts of stuff, absolutely.
Yes. Okay. So then another question is, do you foresee any challenges to make use of RISC-V to develop the solution or product for AI? Wei-Han, do you have any comment?
I absolutely feel there's no problem, no something, anything. I think this is a great standard. Like it actually invented at the right place at the right time. 就中国话讲就是无心插柳反成荫啊。这个就是一个 this technology developed in 2010, and you see my chart AI model acceleration at 2012. It just collide together and work perfectly. Right? It's such a wonderful thing because AI requires so much customization, and then AI had to be everywhere. This is actually give you the freedom while under the one single standardization. So your software stack, if you understand my scalability, right, it can be consistent. The same software ecosystem all the way from the client device all the way to the HPC world, right? Nobody can do that in this time, right? So it's a wonderful thing actually happen at the right place at the right time. I don't see there is any problem, but just when we be careful about is about the introducing too much complexity to this ISA, make it fragmented. I working with the army in Apple, right? Every ISA is being reviewed with a careful study, hardware study, performance study, compiler study, being able to justify the existence of the instruction in that ISA. I respect that kind of due diligence to do, and I think the RISC-V should doing that as well. When you propose something, be extremely careful about what's the implication on the implementation and usage. Don't put too much baggage on this ISA, right, in the future. Because if you actually do that, you will abandon it, and then ISA will become ugly, become fragmented. It's a bad thing to do. So I just wish that's the case. Yeah.
Okay. Okay. Thank you, Wei-Han. Yeah, I think I agree with Wei-Han. LLM or generative AI are so successful because it's open, right? And coupled with the processor part or the computing part, the other x86 or ARM, they are proprietary, so they cannot catch up with the openness or fast evolving AI. And on RISC-V is an open ISA standard. I think that's why you mentioned that the RISC-V is the best fit for the AI. They can, I think they can evolve very fast together to deliver the most competitive solution to meet the customer requirement. Yeah, so I think that's a very interesting and insightful discussion here. And any question from the audience?
Probably, yeah. I'm from deep computing, and I mass produce RISC-V devices. Now we entered into the point that the software ecosystem is very fragmented. And the reason now, we encounter a lot of problems. For RISC-V to scale, you need a very strong software ecosystem. Just now you say accelerators, Python. No one going to push any change to support RISC-V accelerators. So everybody going to do their own customization of their so-called ecosystem, compiler, whatever. But look at Python, PyTorch, they roll out every 6 months a new versions. So, and at the end, the hardware guys and very lagging behind to upgrading their software ecosystem. Like even Linux kernel support, and you know, for example, right, we have a very good 7 nanometer chips, and then with a very good PCIe, but cannot run on the latest kernel. There's no operating system support it, and you can't run any of the AMD AI car, Tenstorrent car, and NVIDIA cars on it. So it's dead end. So I would say now, by the time now we have 7 nanometer, 12 nanometer, I think all the hardware guys should put more resources in the software and don't fragment it anymore. Otherwise, it's not going nowhere, right? And everybody have a legacy, a bunch of legacy ecosystem, and not going to scale. And the other thing I want to say is the Android support. Without Android support, I think the device is really hard for RISC-V. Lien is not going to do good on the device side. So that's my point. So
that's why Tenstorrent is pushing for open standard, right? Open AI software ecosystem, right? Try to put everybody together and join develop a consistent solution, right? But the Android part, my take on this is that even Google not doing it, China eventually will do it, right? So if Google doesn't do it, China, they have the risk actually, the Chinese would take a version and branching out building the Android. I see actually that starting to happen. I see people actually show me an Android phone based on RISC-V processor. The government actually has a fundamental incentive to moving everything to RISC-V due to the geopolitical tension, right? So Google will have to do the Android. So just patiently waiting a couple, 1 or 2 years, it will happen. Right, that's my observation. Because if they don't do that, they are risk of the fragmented their Android system. They're losing the ad revenue to Chinese maker instead of Google taking itself, right? So I believe that will happen. Just patiently wait. That's gonna happen. Yeah, client device.
I want to comment on this customization. I think customization is for innovation. It doesn't necessarily going to cause issue with software. So if you understand, let's take PyTorch for example. If you understand that infrastructure, whatever you added, the custom instruction and the custom feature should be wrapped inside a particular operator, for example, right? So if you keep enhancing the PyTorch, I don't think you're going to throw away the operator you provide in the past. Same thing for every compiler, there's a microkernel. So you wrap up your custom extension in that microkernel. So even ERI continue to evolve, that your microkernel invoke your specialized instruction should still be there and still working. So it's basically up to how you add your custom extension. I think people know how to work on that already.
I think I will just add on to that as hardware people are waiting for the software to be ready, and software people waiting for a hardware platform to be there, right? So we actually both have to do the job. So it is a leap of faith. It is a new market, new ISA. I think we do have the faith from the engineering community. We see a good technology fit, and we see a very good fit for the market. The market window is also opens, but with any windows open, window also close. So we need to catch the best moment. I always believe as an engineer, I need to convince my boss to take on these opportunities. But if my boss disagrees, it's my fault.
I think the other answer to that question is profiles and platforms, which is how we standardize a baseline that the operating system guys can support, the library builders can support, the compilers can support. That's why those profiles are so important. And beyond profiles, platforms will be the next step. That's really going to drive. And I have to put in a plug for RISE because that's an important organization to bring everyone together and do what you said, get the hardware guys working together to drive the software. So you talk to the folks at the RISE booth later, or come and hear Barna talk.
Yeah. Okay. Everyone.
Okay. This is Alan Su from Whale Chip and the NCKU. One of the questions currently Taiwan facing is that how to train more system architects. And then, I just realized that you are all great top leading architects. But the thing is, training the system architect will take 10 years. Do you have any suggestion or possibility to cut that in half? Any techniques or the ways that we could do?
So anyone?
Join Tenstorrent. You will learn tremendously fast. We will cram you days and night of work, so you will learn tremendous. My take on this, so I design processor. There's no secret sauce. You just have to build that day by day, year by year, doing many generation tape out. It's a very, very hard technology, right? Without the tape out experience, without the system architecture, it's just not going to happen. So if a company cannot do it, country have to sustain building that using this continued pipeline. Like any design team, like I joined Apple with a PSMI, right? We're starting with 150 people. Before I left, Apple growing to 10,000 design team. The first couple generation Apple chip produces awful, right? And then they putting things together generation, but 10 years later, they become a world-class design team. And Apple used to spend like billions of dollars invest on it. Right? There's no secret sauce. You just have to do it. Tape out the chip, coming by, it doesn't work. And you build a resource, you build a person, training in the way that I have to do. There's no secret sauce. It's like a running marathon. You don't run it, you don't get faster. Right? It's very simple. Yeah, there's no way. So country have to spend resource, company have to continue invest to train those people. That's the only way. Apple has the patience, right? Keep investing for 10, 20 years to make that happen. Do you have that resource? Then do you have that will as well? Right? It's very, very, there's no secret sauce. There's no show pass you can cut. No way, yeah.
I fully agree with Wei-Han. Not 10 years, 20 years, or even longer. Right. But I think the key thing is that you don't need to build everything yourself, right? So you should look around to see what kind of expertise you have, and you don't build everything yourself, right? That's how why industry has this kind of IP and build up, and you have chip level and chiplet, using chiplet to build a system. So you should look at where your expertise and use that to kind of use your expertise in the right place. But on the other hand, since we are talking about AI, right? Maybe one day we can have AI for computer architects. But I think Wei-Han would then provide information to that as a training data.
Yeah, just for the record, I've been working for more than 30 years, but I'm not a system architect. So.
Okay, I think the discussion are truly great because I see the time's up for there. So I think that's thanks for the insightful sharing from our esteemed panelists. And I think this afternoon, Frank will host another panel discussion. So if you have something more to discuss, I think you still have a good chance to bring them into the panel discussion hosted by Frank Weil in the afternoon. And thank you all for joining us, and thanks for the panelists.